Hey everyone, welcome back again. In last series we have observed first graph for body at rest, second graph for body traveling at constant velocity, third graph for constant acceleration, fourth graph for displacement under constant velocity and zero acceleration, fifth graph for displacement under constant acceleration. Let's combine all other previous learning of graph. Here, we are to consider different type of graph for constantly accelerated motion. From our previous learning, graph for constant acceleration is a straight line parallel to time axis, while graph for velocity under constant acceleration is straight line inclined to time axis that is linearly increasing. And finally, displacement is increasing in non-uniform manner. Here, the values used in table is obtained from calculation based on equations of motion. In the considered situation, object is at rest at origin. A constant acceleration of 2 meters per second square is acting throughout the motion. Now let's focus on graph of freely falling object. Freely falling means object is falling under the influence of Earth's gravitational pull only. Here we are observing the graph of displacement versus time of freely falling object. Initially, the object is at a height of 125 meters. When the object starts falling, then there is non-uniform decrease of height is taking place, and therefore the displacement time graph shows a curved graph line. Let's now have a look of all other form of graph for an object falling freely from a certain height only under influence of gravitational force. Here displacement is non-uniform while velocity is constantly increasing, but that in opposite direction to the considered positive direction, that is vertically upward, is here taken as positive. So any quantity opposite to the considered direction is taken as negative. The acceleration due to gravity is acting vertically downwards with magnitude with approx 10 meter per second square. Therefore the graph of acceleration time is constant and parallel to the time axis. Now take another graph for an object which is thrown vertically upwards with some initial velocity. Here we can observe that first there is non-uniform increase in displacement and then there is non-uniform decrease in displacement. Finally, the object returned to same starting point, so the final displacement becomes zero. Finally, we are going to have a close observation of all displacement, velocity and acceleration acting throughout the motion. Here in the considered example, object is thrown vertically upward with initial velocity of 100 meters per second. During the motion, acceleration due to gravity is acting all the time. The direction of acceleration due to gravity is vertically downwards. Here again we have considered the upward direction as positive. Therefore, acceleration due to gravity is taken as negative. And there is positive increasing value of displacement in the first half part of motion, while the velocity is decreasing linearly. At the maximum height, the velocity becomes zero and there is change of direction. After this time or maximum height, the velocity starts increasing but in opposite direction, while displacement starts decreasing and finally become once again zero. In this our second series of graph we have observed. First graph of constantly accelerated motion. Second graph of freely falling object. Third graph of object thrown vertically upwards. Hope you all have developed some more understanding of graph. Do the calculation by yourself and then plot the graph points. You will also have the similar graph. You do practice. Hope to meet you all again in next part of graph.